Welcome to What's Next. Imagine two engineers trying to build a power plant. One says, we need 500. The other asks, 500 what? Watts? Horsepower? BTUs? Megajoules? If they don't speak the same language, the project doesn't just get delayed, it can collapse. In the world of energy, units are not decoration. They are the language of reality. If you don't understand the language, numbers are just noise. Today, we're going to learn how to speak like real energy engineers. We're going to learn the global translator of science, units. Because once you master this language, you can read power plant data, understand your electricity bill, compare engines, and analyze national energy consumption, all without confusion. Let's begin. Most of the world uses the SI system, the International System of Units. It's the closest thing humanity has to a universal scientific language. And in energy engineering, three heroes dominate this language. First, the Newton. The Newton measures force. Imagine pushing a shopping cart. The effort your muscles apply to make it move, that's force. The definition is precise. 1 Newton equals 1 kilogram times meter per second squared. In simple terms, if you push a 1 kilogram object and give it an acceleration of 1 meter per second squared, you are applying exactly 1 Newton of force. That's the unit of push. Second, the Joule. The Joule measures energy or work. If you push that shopping cart and it actually moves forward 1 meter, you have done work. You have transferred energy. The definition is elegant. 1 joule equals 1 Newton applied over 1 meter. To make this tangible, lifting a small apple, about 100 grams, up by 1 meter requires roughly 1 joule of energy. That's how small a joule is, and that's why in real-world engineering, we often need larger units. Third, the watt. This is where many people get confused. A watt is not energy. A watt is the rate of using energy. 1 watt means 1 joule per second. Imagine drinking a glass of water. Whether you drink it in 1 second or in 1 hour, the total amount of water is the same. That's energy. But if you drink it in 1 second, your rate is much higher. That's power. A 10-watt light bulb consumes 10 joules of energy every second. A 100-watt microwave consumes energy 100 times faster. Energy is the quantity, power is the speed, and confusing them is like confusing distance with velocity. Now let's solve one of the most common mysteries in daily life, your electricity bill. On it, you always see kWh, kilowatt hour. What is that? A kilowatt hour is not power, it is energy. It simply means using 1,000 watts for 1 hour. But engineers prefer to convert everything into joules when doing calculations. Here's the key conversion. 1 kilowatt hour equals 3.6 megajoules. Why 3.6? Because 1 kilowatt equals 1,000 joules per second, and 1 hour equals 3,600 seconds. Multiply them together, and you get 3,600,000 joules, or 3.6 million joules. Imagine a generator producing 7 kilowatt-hours of electricity. In joules, that equals 7 times 3.6 megajoules, which is 25.2 megajoules. Same energy, different language. A true engineer must be bilingual in units. Now let's zoom out. In energy systems, numbers become huge or incredibly small. That's why we use prefixes. Micro means 1 millionth. Milli means 1,000th. Kilo means 1,000. Mega means 1 million. Giga means 1 billion. Peta and exa go even further. A large wind turbine might produce several megawatts. A large power plant produces gigawatts. A country's annual energy consumption is often measured in exajoules. An exajoule is 10 to the power of 18 joules. That's a 1 followed by 18 zeros. When we speak about national energy statistics, we are no longer talking about apples and shopping carts. We are talking about civilization-scale numbers. Now let's cross the Atlantic. The United States still uses several traditional units. One of them is the BTU, the British thermal unit. A BTU is the amount of energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. It's small. So when Americans talk about national energy consumption, they use something called a quad. 1 quad equals 10 to the power of 15 BTUs. That's a quadrillion BTUs. Another famous unit is horsepower. This story begins with James Watt. He wanted to sell steam engines to farmers, but farmers didn't understand watts. They understood horses. So Watt calculated how much work a strong horse could perform. He estimated that 1 horsepower equals 746 watts. So when a car is advertised as having 200 horsepower, it means the engine can deliver about 200 times 746 watts of power. It's a marketing bridge between the agricultural past and the industrial future. Now let's talk about oil, the black gold of the modern world. Energy engineers often compare everything to oil. A barrel of oil contains about 159 liters. To simplify comparisons between coal, gas, nuclear, and renewables, engineers use a unit called a ton of oil equivalent, or TOE. It answers one simple question: how much oil would you need to burn to get the same amount of energy? By converting everything into a common reference, comparison becomes possible. And comparison is the foundation of rational decision-making. So what did we learn today? We learned that a watt is the rate of energy use. A joule is the energy itself. A kilowatt-hour is simply a larger energy unit used in daily life. Horsepower connects modern engines to the strength of horses. And prefixes allow us to scale from microscopic systems to national grids. Units are not just technical details. They protect clarity. They protect accuracy. They protect property, contracts, engineering designs, and economic calculations. If two engineers disagree on units, investments can be miscalculated, infrastructure can fail, resources can be wasted. But when everyone speaks the same language, cooperation becomes possible across companies, across countries, across continents. You are now fluent in the basic language of energy. And in the next episode, we will use this language to analyze real systems, because without understanding units, engineering is just decoration. Energy is the language of motion. Now you can speak it.